Well, hello everybody, blah blah blah. Welcome to another episode of Saga Saturday, where we make this amazing pen. Today is tube day, so we are turning, one second please. This tube into these tubes. So essentially, we're turning our little groovy detail on there. We're turning and we're facing a tiny little chamfer on the front. We're facing the front. We're boring the inside, making a nice thread surface, and then putting a nice 60-degree chamfer on the inside so that eventually we can put it between centers if we want to, put patterns on it or something. And then threading the inside to a 3B tolerance thread using our 3B thread gauge. This thing's been really good. First batch, we just kind of guessed on thread pitch. I mean, we 3-wired measured some stuff, but now we're getting a bit more serious. So you put the thread gauge in there. It's got a go side and a no-go side. The go side being the minimum. Like if this goes in, you're good. It's not too tight. And then if the no-go side, which is bigger, if that goes in, then the thread is too big. That's bad. So you want the no-go to not go in, like maybe half a turn or 1 turn. Everybody's got a different spec. But the go side, so we kind of play around with how that works. Anywho, currently we're doing this as a 2-op part, meaning do the one side, transfer it, pull it out, cut it off, and then we'll go back and we'll manually put it in the second side to turn it to the right length, to do the threads on the inside and make it perfect. Eventually we're going to make it a single op part, but I just don't really trust myself and the machine and everything to eject the part without scratching it and to pile it up in the or the parts catcher, and I like doing it one by one right now, and they're pretty fast.
Plus the concentricity of that little groove. So
that
tight.
too. Yeah, Angelo was saying the concentricity of our little detail groove is too easy to run out and have problems. We did have problems on the first batch with that. So bit by bit, we're just trying to make it better and faster and more accurate. And then last week, we've been picking away, check this out. We've been picking away at all of these titanium tips. Now, I don't think we filmed any of it just because we were busting through it and not thinking too much about filming, but they turned out amazing. And they thread together amazing. Oh yeah. They made up perfectly and they look really good. Everything's gonna be tumbled. Even the little chamfer in the front, I wanted it perfect. I wanted it to look just perfect so that when the pen goes together, the tip sticks out just the perfect amount. Everything looks good, everything's detailed. We're looking at these parts under the microscope, just trying to get everything totally dialed. This part's not that difficult to make, but the setup for it is kind of tricky because there's a specific weird size drill bit that we do there, because we found that if it's too tight, your ink won't go through, and if it's too loose, your ink will wobble around. So as you're writing, you can feel that ink wobbling around. So we're trying to find this perfect balance point for the size of that drilled hole. And then the engraving, we had to get the depth of that perfect, the position of it perfect. Get the threads dialed in nice. They're a little burry right now. And on the next batch, I want to incorporate a Higby thread. Maybe Aaron can show a close-up picture of an example of that in the overlay of the video, but it gets rid of those burrs and it makes the threads super duper duper nice. So that's kind of my long-term plan, is to get that integrated as well. And then on the inside, there are, I think, 3 different diameters and dimensions to allow the spring to seat properly, the ink to go in nice, and just to make an epic part. So it did take some dialing in to get it perfect, but once it was running, we were just like, it's running, it's going good, it's working, let's just keep making more, keep making more. So we made 150, and they worked out really, really well. Very happy with that. A couple weeks ago when we were making the first mechanism batches, we were like, okay, let's just make 50, make sure it all works. So we made 50 of that part, 50 of that part, and then another part was going really well, made 150 of that, 150 of this. So we're a little staggered just because we got a little addicted to the progress of of making good parts. So there'll be 50 plus of some of the parts, and then we'll catch up eventually. So I was talking about a Higbee thread. This is a close-up of our 3B thread gauge, and they put a really nice one on there. So you see that front thread right there? It's kind of blunt, it's dull. It's been turned down or ground down in their case. And they actually did it on front and back, which is super sick. So right there you can see it on the back side. And what that does is it just gets rid of the burr, and it allows the threads to go together very nicely. Ideally you have the same on male and female on the inside and the outside threads, so that they go just together perfectly. Obviously they're using some sort of grinding tool here, but you can even just use a grooving tool while threading. So you do the threading and then you groove it afterwards. And there's a few different ways to terminate the thread like that. And what we're doing on our threaded sleeve is we don't have that. And you can see it's a little bit burry. It's not a big deal. We're probably gonna go hand deburr a lot of these, just get them super nice. But imagine how epic it would be if we added that Higbee. Obviously they are the same thread, no wonder why they're so similar looking.
Yes, it looks like an active thread.
Right, yeah, the threads look differently because one's a plug gauge. It's not a fastener. It's not, you know, a thread's not supposed to look like this. This is supposed to go inside of a thread. So that's why our thread looks sharper points, and this one's got duller points. They're just different. I mean, our thread is beautiful except for the burr on the front and the back. So, like I was saying, eventually I want to make that a Higbee thread. I just honestly gave up, didn't have time. It's like, let's move on, let's get the first batch out, let's make them. If the threads are looser, they'll go together, but then they'll like be off center, right?
Yeah.
I remember I learned that back like 2010, I was making blow-off valves for cars, and I was trying to figure out concentric threads, and every time I put it together, it would go off center.
Yeah.
And I couldn't figure out why until I asked some engineering guy, and he's like, most threads will have either a locating boss and like a feature or a taper. So I made that part a taper. But here we're trying to make the thread like so tight.
It's a close thread.
It's a really close thread. So this is a 3B tolerance thread. 2B is like a regular fastener, and I think 1B is like a crappy IKEA screw or something, like really low
and
end.
There's A and B depending on your
inside, outside.
So,
but 3B is like primo.
It's where we want to be. You can use this type of thread now to do a positional tolerance within like 5 thou. So, you know, 2 thou in each direction. And the way you would locate that on, say, a fixture or something using this thread is you use a tooling ball using the threads, and then the tooling ball is ground concentric to the threads, and you would probe that to determine your position of your thread. So you can actually do tight tolerancing on this type of thread.
Crazy.
For position, which is what we're doing here. Now we can actually spec a concentricity from the OD to the thread of like 5/10 and maintain it.
Yeah.
Which is what we're seeing here. So these come together, and you know, you're not going to feel a mismatch.
Right. Definitely don't want to feel any mismatch. Definitely want a nice feeling thread, because not only do you have to take it apart to get the ink out, but I mean, everybody's just going to fiddle with it and take it apart. Like, you want it to be nice.
And in the future, once we add a bit of a Higbee, a start-stop, it's not used much in, you know, most applications. It's more for like fire hose, like a thread gauge where you're constantly putting a thread in and out. It helps you not to damage that thread. But in most applications, it's not done. So we're going to go above and beyond, of course, because we know people are going to be taking these apart a lot. So, you know,
it's got to be the best.
Yeah, exactly.
Because we are the best of the best of the best, sir.
Yeah.
Okay, so we're making tubes right now. It's a 1x1 op. A little tedious, but it's fine.
Yep. It's pretty standard for most jobs, right?
So what are you doing there?
Just getting off some of the coolant before I put it in there. Lots of swarf.
I noticed a lot of the threading chips, it like makes a little ball inside the tube.
Yeah, so that helps me get that out.
So it's like when you blow it, it's like a spitball.
Yep. Yeah, that way we don't really need to clean them yet because they're going in for a second op, but I don't want to, you know, if you're doing the next job, I don't want to give you something that's sticky and, you know, gross, especially if we're looking for a lot of concentricity. On the next, we want a nice clean outside diameter. Yeah. Whereas if
that's a good point. Oil or chips or dirt or dust or something, we got a good stack going on here. So what's our counter at?
70 something.
77.
So I got some little, there's a little chip inside.
Inside the collet, so when the collet goes to grip on it?
Yeah, the collet went to grip. There might have been a chip on the outside. It went inside, probably when it goes to grab it the second time.
Yeah.
And then it binds a little bit, try and pull it out, creates a little micro scratch.
Like normally they come out of the sub collet super easy.
Yeah.
But then there were two that were like, couldn't get it out, yeah.
So it created a tiny little scratch, probably like a thou deep. I don't want that, you don't want that, scratch.
Customer doesn't want that either.
Like we could probably try and work that out, polish it, but
right. I mean, yeah, scrap or AKA my next pen.
Yeah, exactly.
Yeah, talk about the scrap ones. Where'd you put them?
In the scrap bin. So I got some little, there's a little chip inside.
So yeah, it's interesting because as the machine, it's going, it's warming up, it's getting a little bit, you know, the tolerances get a little bit tighter or looser depending on the temperature. The coolant warms up. Tolerances do grow, they shift ever so slightly, so we're constantly playing with the tool wear offset for the threading tool to make that perfect thread. It's pretty tight range.
Small window.
Yeah.
But you feel a big difference, so.
So on this particular part right here, Angelo was saying that the thread felt super weird near the bottom. Like maybe there was some little piece of grit or some grossness inside. So I'm looking under the microscope right now, trying to see anything. I don't really see it.
Weird.
Maybe some galling.
Yeah.
Not really like a chunk of something. Galling is like when metals just smear. So for the time being, we're using this awesome tubing that we found. It is grade 9 titanium, which is super epic. A little bit different than the grade 5 titanium we're using for all the other parts. So sometimes they anodize ever so slightly different. Like if you make it purple and make the tip purple at the same voltage, they're going to be ever so slightly different. You guys might never notice, but we notice when we're anodizing and it kind of bugs us. You can't buy extruded tubing in the other grade because it doesn't flow well enough through the extrusion process, yada, yada, yada. So long term, we might look into drilling the tube and turning the outside from a bigger diameter, give us full control over the surface finish, the size, and all that. Yeah, I might definitely look into that at some point. But for now, this works great. Thanks for joining us on this totally tubular Saga Saturday. It's very exciting because the tubes are the second last part we have to make, and then the clips will be next. So we'll have the tubes done today, I figure, and then the clips over the next few days. Clip's a big deal. It's a long run project. It's like a 20-minute cycle time. We're going to try to shave it down to like 15 maybe. 12 would be epic. I'll see what I can do eventually. But yeah, I'm excited because then once we have clips, once we make one clip, we can finish and ship one pen. So they'll be kind of like one piece flow at the end because everything else is done now. So I'm excited for that. That's the next couple days, probably next video. We're going to assemble mechanisms and get it all ready to go. Polishing, anodizing, everything. So thanks for watching, guys. Bye.
One more thing. I almost forgot. We're editing the video right now. Aaron's doing it. And please sign up for the Saga list. If you guys are interested in this pen, we have created a page on the website. Aaron's going to put a link in the description. Just look down there. Saga page on the website. There's a sign-up form. It goes into our Maker's Choice system where people are randomly chosen to buy the pens as we manufacture them. Just like how we do for the knives. It's a sick system. It works awesome. So sign up if you're interested. This is our official YouTube announcement, the first announcement for the pen list. So sign up, right?
Yeah, sign up.
Yeah, let's do it. You're not signing up. Why are you still watching? Go sign up.
Go.
All right, bye, guys.